We are proceed to topic matrices. What is matrix? During secondary school, you are learn about 2 times 2 matrix. That means 2 times 2 matrix contains 2 rows and 2 columns. 2 times 2 is called order of the matrix. In the general form of a matrix with m rows and n columns. M rows and n columns. What is the meaning m rows and n columns? This is the first row, second row, third row until m rows. And then this is the first column, second column, third column until n column. So the order of this matrix is m times n. For the example, A11 is the element at the 1 rows, 1 columns. A23 is the element at 2 rows and 3 columns. And A32 is the element at 3 rows, 2 columns. For the example, this is the matrix in order 2 times 3. That means the matrix contains 2 rows and 2 columns. This is the matrix in order 3 times 3. That means this matrix contains 3 rows and 3 columns. Both of them we call order of matrix. Here we are learn about type of matrices. The first type of matrices is row matrix. Row matrix is a matrix has only one row. Example matrix A. The order of matrix A is 1 times 3. So you can see here the number of row is 1. And then the next type is column matrix. Column matrix is a matrix has only one column. Example matrix B. The order of matrix B is 3 times 1. You can see here the number of column is 1. And then the next one is zero matrix. Zero matrix is a matrix which every entry is 0 and denoted by 0. All the entries are 0 here. Okay, this is 2 times 3, 2 times 2, 2 times 2, and then this is 3 times 3. The next is identity matrix. Identity matrix is a diagonal matrix in which all its diagonal entries are 1. Okay, denoted by I. This is in order 2 times 2 and this is in order 3 times 3. And then the next is diagonal matrix. Diagonal matrix which non-diagonal entries are 0. Okay, non-diagonal is 0 here. The next type is lower triangular matrix. Lower triangular matrix is a square matrix where Aij is 0 if I less than j. Example A12 where I is equal 1, J is equal 2. So, I less than J. When I less than J, the element of A12 is 0. And then the next step is upper triangular matrix. Upper triangular matrix is a square matrix and Aij is equal 0 if I greater than J. For the example A3, 1, where I is equal 3, J is equal 1. And then I greater than J. So, A31 is equal 0. And the last type is square matrix. Square matrix is a matrix which has the same number of rows as column. Example, matrix A. The order of matrix A is 2 times 2, where the number of row is 2, the number of column is also 2. So, the number of row is equal the number of column. Matrix B. The order of matrix B is 3 times 3. The number of row of matrix B is 3 and the number of column matrix B is 3. So, the number of row is equal the number of column. So, matrix B A and matrix B are square matrix. Now we are learn about transpose matrix. Let's say matrix A. Matrix A in order 2 times 2. Transpose of a matrix A written as A transpose. So, how to get the A transpose? A transpose is the matrix obtained by interchanging the rows and columns of matrix A. First row 1, 2, change to the column. And then the second row 3, 4, change to the column. This is the A transpose. Example is matrix B. The order of matrix B is 2 times 3. So what is the B transpose? B transpose is interchanging the rows and column of matrix B. First row 1, 2, 3. Change to first column 1, 2, 3. Second row 3, 6, 7. Change to second column 3, 6, 7. So this is the B transpose. Operations on matrices. The first part of the operations on matrices is addition and subtraction. How to do the additions and subtraction process in matrices? Now we are given 3 matrices here. Matrix A in order 2 times 2. Matrix B in order 2 times 2 also. Matrix C in order 2 times 1. How to do the additions between matrix A and matrix B? You can see there, matrix A and matrix B have the same orders. So the additions between matrix A and matrix B is defined. Matrix A the element of A11 plus matrix B, the element A11, that means 1 plus 4, the answer is 5. The elements of matrix A, A12, and the element of matrix B, A12, that means 2 plus 3, the answer is 5. The elements of matrix A, A21, plus the element of matrix B, A21, that means 3 plus negative 5, the answer is negative 2. The elements of matrix A, A22, and the elements of matrix B, A22, that means 4 plus 6, the answer is 10. How to do the subtraction process between A minus B? Since matrix A in order 2 times 2 and matrix B in order 2 times 1, so the matrices have same orders. That means matrix A minus matrix B is defined. So how to do the process? Matrix A minus matrix B. The elements of matrix A, A11, minus the element of matrix B, A11. That means 1 minus 4, the answer is negative 3. The elements of matrix A, A12, minus the element of matrix B, minus 1, 2. That means 2 minus 3, the answer is negative 1. The elements of matrix A, A21, minus the element of matrix B, A21. That means 3 minus negative 4, that means the answer is 8. The element of matrix A, A22, minus the element of matrix B, A22, that means 4 minus 6, the answer is negative 2. So you can see there the operations of addition and subtraction in order 2 times 2, same order of matrix A and matrix B. How about A plus C? The order of matrix A is 2 times 2, but the order of matrix C is 2 times 1. Since matrix A and matrix C have different order, so different order, that means matrix A and matrix C, the process of additions is not defined. This situation we call incompatible. So we are going to continue about the scalar multiplications. That means how to find 2a minus 3b. Okay, 2a. That means matrix A is multiplied by the scalar 2 and matrix B is multiplied by the scalar 3. So 2 multiplied by matrix A 1, 4, 5, 3, and minus 3 matrix B 3, 6, 2, 4, 3, 6, 4, 2. So you must multiply scalar which the matrix first. 2 times 1, 2, 2 times 4, 8, 2 times 5, 10, 2 times 3, 6, minus 3 times 3, 9, 3 times 6, 11, 3 times 4, 12, 3 times 2, 6. So and then you do the subtraction process. 2 minus 9, the answer is negative 7. 8 minus 18, the answer is negative 10. 10 minus 12, the answer is negative 2. 6 minus 6, the answer is 0. So this is the answer. going to proceed about multiplications of matrices. The multiplications of matrices is defined only when the number of columns in the first matrix is equal to the number of rows in the second matrix. Let's say matrix A is the first matrix in order 2 times 3, and matrix B is the second matrix in order 3 times 2. You can see here the multiplications of matrix A and matrix B is defined because the number of columns of matrix A is equal the number of row of matrix B. So the answer must be in order 2 times 2. So how to do the process of matrix A and B multiplication? Let's say matrix A times matrix B. You rewrite matrix A and matrix B. So the answer is how to do the process. The first row of matrix A multiply the first column of matrix B. That means 1 times 2 plus 2 times negative 3 plus 3 times 2. And the second one, the first row of matrix A multiplied by the second column of matrix B. That means 1 times 1 plus 2 times 4 plus 3 times 1. And then the second rows of matrix A multiplied by the first column of matrix B. Negative 2 times 2 plus 0 times negative 3 plus 5 times 2. And the next negative, that means the second row of matrix A multiplied by the second column of matrix B. Negative 2 times 1 plus 0 times 4 plus 5 times 1. So the answer is, after you simplify, 1 times 2, 2. 2 times negative 3, negative 6 plus 3 times 2. So 2 minus 6 plus 6. The answer is 2. 1 plus 8 plus 3. The answer is 12. Negative 4 plus 0 plus 10. The answer is 6. Negative 2 plus 0 plus 5. The answer is 3. This is the answer of the product matrix A and matrix B. The answer in order 2 times 2. Determinant of matrices. If A is the square matrix, the determinant of A is denoted by that A. Or absolute of A. So you can write absolute and write all the elements of A inside. So how to calculate determinant of A? This is the first diagonal. You multiply the number along this diagonal. That means 3 times 8 minus and then multiply along this diagonal, 5 times 7. So the answer is 24 minus 35. This is the negative 11. This is the determinant of A. How to find determinant of 3 times 3 matrix? For example, matrix B. To find determinant of matrix B, we can write absolute of matrix B like this, or we rewrite all the elements of matrix B inside the absolute signs like this. Before that, we write the signs first. All the elements of matrix B. For A11, the sign is positive. A12, the sign is negative. A13, the sign is positive. A21, the sign is negative. A22, the sign is positive. A23, the sign is negative. A31, the sign is positive. A32, the sign is negative. A33, the sign is positive. Click the determinant of matrix B. Here we choose first row. You can choose second row and third row, or you can choose first column, second column and third column. The first element of the first row is 2. The sign of 2 is positive. So we write the positive 2 here. And we delete the first row and the first column. You can see here what are the number is not deleting. That's are negative 6, 3, 2 and negative 3. Put in the absolute sign here. And then do the similar thing to the A12. The size of A12 is negative. A12 is 3. And then, by using the red color here, we delete the first row and the second column here. So, what are the number is not deleting by the red color? That's 5, 3, 4 and negative 3. Continue for the A13. The size of A13 is positive. And then A13 is negative 4. By using the yellow color, we delete the first row and the third column here. So what is the number is not deleting by the red color, by the yellow color, sorry. The numbers are 5, negative 6, 4, 2. To calculate, we calculate like find the determinant matrix 2 times 2. That means positive 2. Calculate, multiply negative 6 and negative 3 is 18. Minus the opposite calculation here, 3 times 2. Minus 3. 5 multiplied by negative 3 is negative 15. Minus the opposite multiply is 3 times 4 is 12. Positive negative is negative. And then 4 multiply 5 and 2 is 10. Minus the opposite, 5 times negative 6 is negative 24. And then after you press your calculator, you can find the answer is negative 31. That means determinant of matrix B is negative 31. Example, we choose the second column. The first element of the second column is 3. The sign of 3 is negative. So, this is the second column here. We start negative 3. And then delete the first row and the second column here. So what's the number is not delete here. 5, 3, 4, -3. So the next element is -6. The sign of -6 is plus. So we delete the second row and the second column here. So what is the number? What's the number is not deleting here? 2, -4, 4, -3. The next element is 2. Positive 2 is positive 2. Positive 2. The sign of 2 is negative. So we delete the third row and the second column. So the numbers is not deleting here to -4, 5, 3. And then we do the calculations. -3. 5 times -3 is -15 minus 12. Plus minus is -6. -6 minus -16. -2. 6 minus -20. -3, -27, -6. -6 minus -16 is 10. -2 and then 26 here. This is the 81 minus 60 minus 52. The answer is -31. Properties of determinant. Properties 1. If the elements of one row or one columns of a determinants are 0, so the value of the determinant is 0. For the example, determinant of matrix A. Determinant of matrix A is determinant 1, 2, 0, 0. You can see here the second rows, all entries are 0. So the value of determinant is 0. And then let's say determinant of matrix B. Determinants of matrix B, the elements are 5, 0, 3, 0. You can see here the second column, all the entries are 0. So the value of determinants of matrix B is 0. The second properties. If two rows or two columns of a determinant are interchanged, so the value of the determinants is multiplied by -1. For the example, determinant of this matrix 1, 2, 3, 4 is equal -2. So you interchanging columns, you can find 2, 4, 1, 3 interchanging columns. That means determinant of this matrix you multiply by negative, maknanya -2 multiply by negative here. So the answer is 2. And then interchanging row 3, 4, 1, 2. So the determinant values here -2 multiplied by negative, the answer is 2. The next properties 3. Determinant of A is equal to determinant of A transpose. Okay, so determinant of matrix A 1 2 negative 1 0 is equal to, so determinant of A transpose (1) negative 1 2 0 are equal to also. Properties 4. If the elements of one row or one column of a determinant are multiplied by k, the value of the resulting determinant is k times the given determinant. The example: determinant of this matrix is equal 5. So, determinant of this matrix, you can write like this. Put outside 4, you can find there 2, 3, negative 1, 1. So, 4, what is the value of this determinant? 5. So 4 times 5. The answer is 20. Properties number 5. If two rows or two columns of a matrix are equal, so it has 0 determinant. For the example, determinant of this matrix is equal 0 because row 1 and row 3 are same. Next example. What is the determinant of this matrix? You can see here, when you put 3 outside, you can find the determinant of this matrix is equal 3 times 0. That is the 0. Because the first row and the third row are same elements. Properties number 6. If determinant of this matrix is given equal to 3, and then what is determinant of this matrix? So how to do? How to find for this determinant? You can see here, the second row are changed. From 0 change to 6. From 1 change to 5. So, first row are same. So, second row, that means first row times by 2 plus second row. That means plus 0. And then first row times by 2 plus second row. That means plus 1. So for the second row, you can find the value is 6 and the value is 5. If we add or subtract a multiply of one rows or one column to another, the value of the determinant is unchanged. So the value of this determinant is still same, is equal to. Properties number 7. We are given 3 determinants of matrix. How to find of this determinant of this matrix? This is determinant of upper triangular matrix. This is determinant of lower triangular matrix. This is determinant of diagonal matrix. So how to find all these determinants? Determinant of a lower triangular matrix, upper triangular matrix, and diagonal matrix is the product of the element on the leading diagonal. So what is the leading diagonal here? For the upper triangular, the leading is here. This is the leading for the lower triangular. This is the leading for diagonal matrix. So to find determinant of this is multiply all the elements on the leading diagonal. So 1 times 5 times 3. The answer is 15. For this, 2 times 6 times 2. This is the answer, 24. And this, the value of determinant is 2 times 3 times 4. The answer is 24 also. And properties number 8. The properties of determinant is determinant of AB is equal determinant of A times determinant of B, where A and B are matrices. Example: matrix A 1, negative 2, 3, 4, and matrix B 2, 0, negative 1, 1. So find the product of matrix A and B. You can find that this is matrix A times by matrix B. So the answer is and then the determinant of matrix AB is equal 4 times 4 minus negative 2 times 2. The answer is 16 plus 4. So determinant of matrix AB is 20. Determinant of matrix A is equal 1 times 4 minus negative 2 times 3. So the answer is 4 plus 6 is equal 10. Determinant of matrix B 2 times 1 minus 0. The answer is 2. Determinant of matrix A times by determinant of matrix B is 10 times 2. The answer is 22. So for the conclusion, you can get determinant of matrix AB is equal determinant of matrix A multiply determinants of matrix B. Apply the properties of determinant in the questions. Here, this is the example. Use the properties of determinant to find the value of x. This is the x here. From here, you know that the first row of this determinant is changed to the first column of this determinant. The second row of this determinant is changed to the second column of this determinant. So, you can conclude the third row of this determinant is changed to the third column of this determinant. This means the properties you should use here, determinant of A is equal determinant of A transpose. You can conclude the value of x is equal to. This is the determinant equations. You want to find the value of x. This is the determinant of upper triangular matrix. So how to find the determinant of upper triangular matrix? First, determine the leading diagonal. This is the leading diagonal. And then, you multiply all the entries of the leading diagonal. That means 2x, 2 times x times 1 is equal 6. So 2x is equal 6, x is equal 3. We are going to learn about how to find inverse of 3 times 3 matrix. There are 3 methods to find inverse of 3 times 3 matrix. Now we are going to use first method. The method is adjoint. So the objective is find the inverse matrix using the adjoint method. Let's say A is the 3 times 3 matrix. To use the adjoint method, the first step is find the determinant of matrix A. You have learned about determinant from the previous class. Here we choose the first row. So, determinant of A, choose the first row here. So, determinant of A is A11. The sign of A11 is positive. And then, deleting the first row and the first column. The number is not deleting here. 2, 4, 1, 3. Go through to the second element, A12. The sign is negative 2, and then deleting the first row and the second column. You can find that the number is not deleting here are 3, 4, 1, 3. Continue to the next element, A13. A13, the sign is positive. So A13 is 3, and then deleting the first row and the third column here. So the number is not deleted, 3, 2, 1, 1. And then you calculate determinant. 1, 2 times 3 is 6, minus 4 times 1 is 4, minus 2. 3 times 3 is 9, minus 4 times 1 is 4, plus 3. 3 times 1 is 3, minus 2 times 1 is 2. So you simplify 6 minus 4 is 2, minus 2, 9 minus 4 is 5, plus 3, 3 minus 2 is 1. So determinant is 2 minus 10 plus 3. Determinant of A here is negative 5. Next step is find the minor of matrix A. We start from M11. What is the meaning of M11? M11 is the determinants of the matrix obtained by deleting the first row and the first column. We rewrite the elements is not deleted here. 2, 4, 1, 3. So calculate the value of determinant. 2 times 3, 6, minus 4 times 1, 4. So the answer is 2. This is the value for M11. Continue to M12. M12 is the determinant of the matrix obtained by deleting first row and the second columns. 1, 2, 3, 3, 2, 4, 3, 1, 1, 3. Deleting the first row and the second column. So, we rewrite the element is not deleted here. 3, 4, 1, 3. So, this is M12. And we calculate again. 3 times 3, 9, minus 4 times 1, 4. So, the answer is 5. To find M13. M13 is the determinant of the matrix obtained by deleting the first row and the third column. We rewrite the element is not deleted here. 3, 2, 1, 1. And then calculate determinant. 3 times 1, 3, minus 2 times 1, 2. So the answer is 1. This is the value for M13. Continue to the next row. M21. We will find the value is 3. M22, the value is 0. M23, the value is negative 1. M31, the value of 2. M32, the value is negative 5. And M33, the value is negative 4. Third step is find cofactor of matrix A. The symbol of cofactor is capital of C. How to write the cofactor? We arrange all the minor into the one bracket. This is M11. This is M12. This is M13. This is M21. This is M22. This is M23. This is M31. This is M32. This is M33. And then we write the signs of all the elements of cofactor. For M11, the sign is positive. M12 negative, M13 positive, M21 is negative, M22 is positive, M23 is negative, M31 is positive, 32 is negative, and M33 is positive. Cofactor of matrix A is 2, negative 5, 1, negative 3, 0, 1, 2, 5, negative 4. And then the fourth step is find the adjoint of matrix A. How to find the adjoint of matrix A? This is the symbol of adjoint of matrix A. C transpose. That means cofactor of matrix A transpose. What is the cofactor of matrix A? 2, -5, 1, -3, 0, 1, 2, 5, and -4. Transpose. So how to transpose the matrix? That means row change to column. 2, 5, -4. This is adjoint of matrix A. Last step is find the inverse of matrix A. Using formula, A inverse is equal 1 over determinant A multiplied by adjoint A. So from the previous calculation, you know that the determinant of A is -5 and adjoint A. What are the elements of adjoint A? 2, -3, 2, -5, 0, 5, 1, 1, -4. So the inverse of A. This is the symbol of inverse of matrix A. Is equal 1 over determinant of A is -5 multiplied by adjoint A. 2, -3, 2, -5, 0, 5, 1, 1, -4. A inverse is the matrix. A inverse is the matrix. So the A inverse must write in the matrix form. -1 over 5 is multiplied inside with all the elements of adjoint A. So the answer is -2 over 5, 3 over 5, -2 over 5, 1, 0, -1, -1 over 5, 1 over 5, and the last one is 4 over 5. This is the final answer for A inverse. To find the inverse is by using the property AB equal K, where A and B are the square matrix and K is constant. If AB is equal I, so we can conclude that BA is equal I. That means B is equal A inverse, or A is equal B inverse. If AB is equal KI, so A inverse is equal 1 over KB, or B inverse is equal 1 over KA. Number 1. A inverse is equal I, where I is identity matrix, or A inverse A is equal I, where I is identity matrix, and I I times A is equal A, or A times I is equal A also. So, how to find inverse matrix using the property of AB is equal K? It's given matrix A and matrix B, where matrix A and matrix B are square matrix 3 times 3. If it's known that AB is equal KI, the equations of matrix is given here, where K is constant and I is an identity matrix 3 times 3. So, finds K. And the second question, deduce A inverse. For the first question, we start from the equations of matrix given. AB is equal KI. Substitute matrix A and substitute matrix B and substitute identity matrix. After you multiply matrix A and matrix B, you will get the answer is 2, 0, 0, 0, 2, 0 and 0, 0, 2. And then take out the value of 2 outside, you will get 2 times identity matrix here. And then you can find the equations of matrix 2i is equal ki. After you compare, you will get the value of k is equal 2. For the second questions, how to deduce A inverse? You substitute K is equal to, and then you will get the equations of matrix is AB is equal to I. And then you multiply both sides with A inverse. You can see here the positions of A inverse are same for both sides. And then A inverse times A, you will get identity. Okay. And then identity matrix times matrix B, you will get B. A inverse times I, A inverse. Any matrix which you multiply by the identity, you will get the own matrix. So, A inverse A is equal 1 over 2B. You substitute matrix B, 1, 1, negative 1, negative 10, 4, 2, 7, negative 3, negative 1. So, you will get A inverse. Multiply 1 over 2 inside with the all element of matrix B. You will get the A inverse in the matrix form like this.